Hello everyone. In this session, we will be discussing some of the basic concepts of field effect transistor or FET in short, and also its classification. And this is its symbol. First of all, let us discuss how exactly FET works. Okay, FET is actually a voltage operated device in which the voltage applied is used to control the current flowing through it. Okay, and it is also known by the name unipolar transistor. That is because they undergo an operation of single carrier type. Okay, by single carrier type, what it means is, in case of field effect transistor, only one type of charge is used for conduction from drain to source. Okay, that is, it could be either electrons or holes. Fine. So next is about the input impedance. Input impedance is high in all forms and types of FET. Okay, the conductivity here is regulated with the help of applied voltage from the field effect transistor's terminal. Okay, and the density of charge carrier affects conductivity in this case. Okay, okay, so a FET transistor is a device with three major components: source, drain and gate. Okay, when voltage is applied between gate and source, this voltage generates an electric field. So by controlling voltage or electric field, we can control the current flowing between source and drain. Hence it is called as field effect transistor. As we can see here, the source is one of the terminals of the FET transistor through which most of the carriers enter the bar. The drain is the second terminal through which majority carriers lead the bar. The gate has two terminals which are internally connected with each other. Since the gate in a FET transistor is in reverse biased, the gate current is practically zero. The drain supply is connected to the source terminal, leading the electron flow which provides the necessary carriers. So this is basically used as an amplifier, switch, multiplexer, current limiter, and one thing that we should note here is that p-channel FET also operates in the similar fashion as n-channel FET, except that the channel current carriers will be holes instead of electrons, and all the polarities will be reversed. Next, we'll be discussing about the types of FET transistor. They are junction field effect transistor and metal oxide semiconductor field effect transistor, that is JFET and MOSFET. Okay, so the main difference between the two major types of FET transistors, that is JFET and MOSFET, is that JFET or junction field effect transistor is a three terminal semiconductor device, whereas MOSFET, that is metal oxide semiconductor field effect transistor, is a four terminal semiconductor device. JFET can only operate in the depletion mode, while MOSFET can operate in enhancement as well as depletion mode. The input impedance is higher in MOSFET, making them more resistive. In comparison to the price, MOSFET is more expensive than JFET. Due to high input impedance, FET transistors are commonly used in and as input amplifiers in electronic voltmeter, oscilloscopes and other measuring devices. They also occupy little space, which makes them more efficient for other devices. So here we can see N channel enhancement type MOSFET, P channel enhancement type MOSFET, N channel depletion type MOSFET, and P channel depletion type MOSFET. Okay, so these are the different classifications within a MOSFET. Okay, and we'll be discussing about each one of them in the upcoming sessions. And this is what we have in JFET. Okay, so here we have N channel JFET, P channel JFET, and these are its symbols. Okay, so that was all about FET. Thank you.